Good morning, everyone. Myself Devika, working as assistant professor in the Department of Electrical and Electronics Engineering at ST Tikumaran Institute of Technology. Today, I am going to present you a topic on fuse, which is a basic protective devices used in electrical and electronic systems. This topic is a part of basic electrical and electronics engineering. In this presentation, we will discuss the concept, construction, working principle, characteristics, and application and limitations of fuses. Introduction. An electric power system consists of different components used to generate, transmit, and distribute electrical energy. For safety, protection devices are required to prevent damage due to overcurrent or short circuits. One of the simplest protection devices is the fuse. It is invented by Thomas Edison in 1890. A fuse works on a simple principle. That means when current exceeds a safe limit, the metal element inside the fuse melts, breaking the circuit and protecting electrical equipment. Fundamental components, concepts. There are some important terms related to fuses. Fuse, a protective device that breaks the circuit when excess current flows. Fuse wire, the thin metal wire that melts when current exceeds the limit. Then fuse link, it is the replaceable part of the fuse that must be changed after the fuse blows. Then fusing factor, the ratio of minimum fusing current to rated current. Then fuse link operation includes a heating of the fuse element and arc formation before the circuit is interrupted. These concepts helps us understand how fuse protection works. Then components and construction of fuses. A fuse mainly consists of two parts. One is outer casing, next one is fuse element. The outer casing protects the fuse element and is usually made of materials like ceramic, glass, plastic, molded mica laminate. These materials provide insulation and heat resistance. Then fuse element materials. The fuse element must have special properties such as low melting point, low electrical resistance, good conductivity, low cost, stable performance over time. Common materials used include zinc, copper, silver, aluminum, metal alloys. These materials ensure the fuse melts quickly when excess current flows. Then key characteristics of fuse parameters. The important parameters of a fuse include rated voltage, rated current, response time. And rated voltage, the voltage rating of the fuse should be higher than the normal operating voltage of the circuit. Rated current, and the maximum current the fuse can carry continuously without melting. A response time. This indicates how quickly the fuse reacts to overcurrent. Fast acting fuses are used for sensitive electronic devices. Cutoff current characteristics. Cutoff current characteristics explain how the fuse interacts current during a fault. Important terms include prospective current, arcing time, total operating time, breaking capacity. Prospective current, the current that would flow if the fuse was not present. Next, pre-arcing time, time taken for the fuse element to start melting. Next, arcing time, so time taken to extinguish the arc after melting begins. Total operating time, total operating, the sum of pre-arcing and arcing times expresses total operating time. That means T is equal to Ts plus Ti. Next, breaking capacity. Maximum current the fuse can safely inject. Voltage drop. The fuse causes a voltage drop that varies with its temperature, so this factor must be considered in circuit design. Construction of a fuse. So, a fuse contains a thin metal wire or strip placed between two terminals. This element is thinner than the circuit conductors so that it helps it quickly when excess current flows in it. Next, the fuse element is enclosed in a fire-resistant casing to ensure safe operation. Next, working principle of fuse. A fuse is connected in series with the circuit. When normal current flows, the fuse element remains intact. When overcurrent or a short circuit occurs, the element heats up and melts, breaking the circuit and stopping the current flow. So this protects the electrical equipment from damage. Next, application of fuses. Fuses are widely used because they are simple, reliable, and economical. So the applications include household electrical circuits, electronic devices, industrial electrical systems, power distribution systems. They provide fast protection against short circuits and overloads. Limitations. Despite their advantages, fuses also have some limitations. They must be replaced after operation. Next, sometimes the time current characteristics may match the equipment. Then, selective coordination between multiple fuses can be difficult. These are the reference of this topic. The information used in this presentation is taken from the following textbooks. In conclusion, the fuse is one of the most simplest and most effective protective devices used in electrical systems. It protects equipment by interrupting excessive current flow and ensures safe operation of electrical circuits. Thank you.